Now, we all know that inverse does not necessarily mean reciprocal. For example, inverse sine, which is on your calculator, does not mean 1 over sine. You all know this, right? Yes. Yes, okay. So this doesn't mean cosecant or something crazy like that.
What?
This is the opposite of a sine function. So the opposite of an exponential function is a logarithmic function.
I still have these in my pre-cal notes.
Sorry, I'm cutting the chase parts that we're going to need. E to the x equals 7. What is E? 2.7 and change, right? It's the only number that when you take the derivative of this exponential function, you get the same number back. It's the only base that's going to make that happen.
So weird.
If I want to change this in the logarithmic form, please note A in this case is E. X is still X and Y is 7. Could you please flip things around and change this from exponential form into logarithmic form? I know you already know how to do this, and this is really easy for you.
So 7 equals E. Wait, what's Y?
What's this?
What is Y?
7.
I thought X was 7.
Log base E, we have a special name
Oh.
for. What do we call that? Natural log. So, let's do this. E to the first power is 2.7, right? E to the second power is going to be, what do you think? 5, 6, something like that. Why don't you go ahead and do that? What's E to the second power?
What's E to the second power?
7.389. Sounds good. So E to the first power is 2.7. E to the second power is 3. What was it? 7.38, whatever. So for sure, X should be between 1 and 2, right? Because second power is too big, just a little bit. First power is way too small. So would you please do natural log of 7 and see what you get? These numbers jug. 1.94, which makes sense because second power gave us 7.3, something like that, so just a little higher. We okay? Let's do this. Could you please solve this equation for X? Switched it around. I got 9x equals the natural log of 4. You comfortable so far? Now I still need to solve for x. What am I going to do? Divide by 9. Can I reduce the 12 and the 9? Yeah, shouldn't be any hesitation. No. For sure no. Okay? How we doing? I would like to see things in this form. I don't want to see decimal form unless I ask for to round it off to 1 or 2 decimal places. Otherwise, I like exact. I'm going to do this.
What just happened?
What just happened? This becomes an exponent. Remember that rule? Yeah. And 12 to the 1/9 power is the same thing as the 9th root of 12. Again, you may go and get an answer like this and feel really good about yourself, then you look in the back and suddenly it's like this. It looks different enough that you're like, oh my god, I got the wrong answer. But in reality, you didn't. We okay? Oh, I don't care. Either one's fun for me. I don't care.
You forgot your calculator?
So let me...
You forget your calculator?
No, that's running out of batteries.
How do you know?
It tells me you're running out of batteries.
Mine doesn't tell me anything. I haven't changed the batteries and things since I got that for pre-cal. Actually, since I got it since trig.
Wow.
When we never used it for trig. Yep, they're all the same, so I don't even need to write them down.
These are our basics. You've seen these before. It's good to recall these.
I kind of want to highlight them now. This is the ones he's doing.
Oh, I use natural log there because that's mostly what we use, but it's any base. It means the same. What's IFF mean? If and only if. That's an if-then statement in both ways. We like those. You've seen me use some of these tricks before. So I want to integrate this. Integral of a to the x dx. What happens here? They reduce out and I'm back to here. Why would I do this? First of all, we don't know what the integral of a to the x dx is. However, when I'm here, I can apply this rule. Bring that x down. Oops. All right, I want you to view it like this. This doesn't look any better than when we started. However, in the exponent, I'm noticing that I have x times a constant. Natural log of a is a constant, right? So if I let u equal x natural log of a, du is ln of a dx. So I'm going to get, oops. We're assuming that a is bigger than 1. Make sure your neighbor understands what just happened.
I wasn't paying attention. What happened? Replace that, yeah. The substitution. Okay. if I could manage that, if he even had it.
Okay, so let's come back. So I did this e to the natural log thing. I actually kind of went backwards a little bit so that I could bring that x down. Again, I'm just doing this. This is like e raised to the 2 times x or something. Natural log of a is just a constant as far as I'm concerned. In substitution in the back here. That's you, right? Now I'm going to do a magic trick.
Kevin, do you have the paper towels? Really? Thank you.
So, the a to the x, I'm claiming is all this. Well, that's where we started, right? That uses log rules. Let's say I do an integral of some sort, and I end up here. This is the result of my integral. I just did all this hard work. I used 10 techniques of integration. I got all the way to here. I got this. I look in the back of the book, and it says this. What happened? Is that true? Can it be the same?
Yeah. Because ln of 2 is a constant.
Yeah, if you separate them out, that's a constant, right?
No.
You're going to see things like this with your textbook. The author does this. Okay. Sometimes. Sometimes he doesn't. Which tells me more than one person is doing this. We okay? Let's move on to differential equations. Let's talk about the even r.